Good morning, everyone. First of all, the title. I'd like to apologize for such a long, wordy title. It wasn't my choice, but my coworker, well, not coworker, my associate chose it, and it was his idea for us to come present this morning. So I figured I'd give it to him. He couldn't be here this morning. Gregory Katz. I don't know if anybody has met him. He works with Louis Berger. So GIS and landscape archaeology along the Anacostia River. So just a really quick, we're going to go over the background of the project, what the purpose was, kind of give you a little bit of an idea of our desired approach, the analysis we ended up doing, and then the field refinement that occurred after the analysis was completed and we actually took our work out into the field. So a little bit of a background, JBAB, Joint Base Anacostia-Bolling, the Cultural Resources Department needed to evaluate what areas they still had to conduct at least a phase 1 survey of upon their base. They knew that there was a large portion of the northern end that was completely fill, and had previously actually been Anacostia River, and there were some areas on the western portion of the base that were also fill. They also wanted to get a good idea of how deep they had to dig in order to start hitting ground that might actually have some cultural significance. So they contracted with Louis Berger and Marstel-Day to complete an analysis to kind of figure out what that area would look like and how deep they had to go dig. And I just said that. And see, that's the area that had previously been fill, or that was mostly fill. So what we ended up doing was we took a number of maps from 1888. We georeferenced them, which sounds easier than what it ended up actually being. We georeferenced them, and we made 3D models. We digitized the contour lines from those topographic maps. And then we performed a raster difference. So the maps from 1888, we georeferenced. We used ArcScan to quickly generate a preliminary coverage of the contours. And then we had a GIS technician come in and do a little bit of refinement. There were a lot of gaps. Certain things were created as contours that were actually roads, buildings, things of that nature. Also, the cliffs that have the symbology that is just outlines coming out, that doesn't scan, that doesn't digitize very well from ArcScan. So a number of things had to be refined. After the contours were digitized, we applied elevation, obviously, to the contours in the attribute table, and we calculated a vertical datum shift. Louis Berger's team had previously done some work in the area, and their initial vertical datum shift was to add 2.2 feet to the existing contour line. So we went ahead and added those 2.2 feet, and we created a 3D elevation model. Once we created that 3D elevation model, we ran a raster service, which is just a common spatial analysis tool, to get what our difference of elevation was between 1888 and today. The raster, or the surface elevation from the current elevation, was collected from LiDAR imagery, and we just downloaded it from the Washington, D.C. area topo line data that they have publicly available. So when we originally georeferenced the maps, we georeferenced it originally off man-made features. I mean, typically when you georeference a map, you do it off roads, building corners, things of that nature. However, we found that there was a problem with that. Many of those features weren't correctly depicted on the 1888 maps. Some of those features had been moved. There was a railroad that had actually been shifted over probably about 20 to 30 meters between 1888 and where it was today. Roads were depicted as maybe 20 to 30 meters wide, where most likely they were much smaller than that, and their edges weren't really really approximate or weren't really realistic according to that time period. Of course, we didn't know that when we ran it the first time. So when we initially ran the raster difference, we were seeing elevation differences of up to 50 feet in places that we knew had not changed at all. We, after banging our heads on the computer a little bit and composing ourselves, we decided to think about what we could do to figure out how to georeference these maps more accurately. So we brought the maps into 3D, both surface elevations, and we overlaid them. And as you can see, there's very clear areas that the elevation was consistent between 1888 and today. The bottom image on your left is the historical elevation. The top image on your left is the current elevation. And we noted there were several areas that we could generally say, well, that's about the same hillside, that's about the same cliffside. And when we overlaid them, they were shifted significantly. What we ended up doing was georeferencing based off the elevation. So we found several areas, not just those four, but several areas on the map where we knew the elevation had not changed between 1888 and today, and we basically just eyeballed it, right? However, once we brought that in and we did the raster surface, we saw that there was a much more consistent result in what we expected as far as elevation difference between 1888 and today. And that's the resultant raster, or raster difference. So once we had the final product, Louis Berger and Geo-Sci consultants went out with this product and actually did some ground truthing. They excavated 23 soil cores and they dug 6 trenches. They actually found a couple of unidentified sites, and they did some further refinement of the model. They found that there was still a little bit of error associated with the expected values, and what they actually found was the true depth to the original surface in the area. But they found that it was a normal pattern. So they refined the model and they calculated the actual difference between the model's calculated depths and actual depths to be within 1.2 feet within 1 standard deviation. And that's the end of my presentation. Any questions?
Question.
Yes.
How could we apply this study? Like, what is the use?
We found that it was very important to have a good understanding of, when we're georeferencing older maps, to have a good understanding of what has changed and what hasn't, and to, as a trained GIS analyst, as opposed to an archaeologist, we're trained to find man-made features and georeference off of that, whereas we really needed to georeference off of the elevation, which was much more accurately depicted on the older maps than they were on today's maps. Yes?
We just asked that you use the microphones so that people watching on live stream, so just have to deal with me running back and forth.
I was just wondering how useful the river level was in terms of determining historic versus current elevations, or was it used at all?
Initially, it wasn't used because when we originally brought the maps, they had no georeferencing at all, and even the coordinates on there weren't correct. So we didn't even have an idea of where to place these maps initially. There was a railroad there, but the railroad on the map was very straight, and the railroad in current curved, and so we didn't even know the scale. So we ended up not using the river elevation.
Did you consider going back to historical photography, or more importantly, historical aerial photography in the 20s and 30s to supplement the data that you were getting off of your 88 maps?
We did. However, most of the aerial photography that we found already had fill in place. So, and what we found was in the 50s of that area, and we didn't find anything, any aerial photography earlier than the 50s, and the fill was already in place. There was no way to reference what the changes in the river based off of the 1888 data. It was already very similar to what we had for current imagery.
I had a question. You said they ruled out area that was previously river historically, but over time, you know, in prehistoric times, that may have been land. Have they thought about, you know, obviously there's a lot of fill, but to be able to analyze that area or predict where the lines would be for maybe prehistoric sites, not just historic?
That was not part of this project. The primary part of the project was to determine where the fill had occurred based off of newer construction in the past 100 years. Any other questions?
I'm curious if you used historical data from adjacent properties. Uphill, there's St. Elizabeth's, upriver, there's other things that have been there a very long time. Could you use those as part of your establishment of a base?
We actually did look at because on the maps that we did georeference, there were some man-made features, there were some streets, a number of streets on the upper right-hand corner, but the depiction of those streets on the maps, we couldn't really count on to be correct. The road names had changed also, and there weren't any significant features on those maps that we could really count on to be depicted correctly on the maps. And they were there on the maps, they just weren't necessarily depicted in the correct location.
Good morning.
Good morning.
I have a question regarding the scale of the resulting raster data set. Maybe I missed it. What was the cell size for your resulting raster set?
We used a 10-meter resulting raster set. Since all of the inputs for the project were actually vector data as opposed to raster, we just chose 10 meters semi-arbitrarily. You're welcome. Any other questions?
All right. Well, if there are no further questions for Diego, thank you very much for the presentation. That was great.